Okay guys, so let's do section 6.5. This lesson is supposed to go over 2 days, 2 class periods, because usually we have lots of discussion. I'm not sure if that's actually going to happen here. I think I'll just go over the whole lesson with you at once, and then maybe give you 2 class periods to do the homework or something. Let's see how that goes. I'll message you and let you know about that. But in any case, let's jump in and talk about this. So last section 6.4 we spoke about how to take samples, and samples are usually what you use when you do observational study or surveys. Okay, and today we're going to talk about and contrast observational studies and surveys with experiments and some of the key features of an experiment. Okay, so here are objectives. Identifying correct bias in survey questioning, identify experiments and observational studies, evaluate a published report. They give us a little blurb and we have to say whether we think it's an experiment or observational study, and then design your own. Okay, design your own. So, your notes say, in designing a survey, it's very important to word survey questions carefully. Answers to poorly worded questions may not accurately reflect opinions or actions of those being surveyed. Okay, so if you, what we call a bad question or a flawed question, we call it a biased question. A biased question will lead to biased results or inaccurate results. Okay, and so below are some ways in which questions can be biased. So the wording of the question may encourage or pressure the respondent to answer in a certain way. The question may be perceived as too sensitive to answer truthfully. Asking someone, hey, have you ever cheated on a test? That would be a sensitive question that they may not want to answer truthfully. Maybe the answer is yes, but they say no because they don't want to look bad. Okay? The first type, let's say encouraging or pressure a respondent to answer in a certain way. You say, hey, this teacher is the best teacher in the school. What do you think? Is he a good teacher? Something like that. And so you're leading the person in a specific way, or just not giving enough information. Okay, so if I ask you a question about, I don't know, what do you think about the specifications of the new Samsung Galaxy S20 Plus or S20 Ultra? Are those good specifications? If you don't know anything about Galaxy S20 Ultra, then you can't answer the question. Okay, so you need information to give an accurate opinion. All right, so these are some ways in which questions can be biased questions that lead to biased results for your sample survey or whatever it is you're doing, okay, your study. So bias may also be introduced in other ways. In other words, the order in which questions are asked, or who is doing the asking. Okay, so the order in which questions are asked is something like, an example that we have in my AP Statistics textbook is, you ask someone, how would you rate your life right now? How do you think you're doing? Oh, great. Or whatever you say, and then afterwards you go, do you have a girlfriend or a boyfriend? And then you say, oh, no, I don't. If you switch the order of the questions around, hey, do you have a girlfriend or boyfriend? No. Or maybe yes. And then, how do you think your life is going? Oh, great. So the order in which you ask the questions can really change things. So also, who's asking the question? So let's say the principal comes to you and says, hey, are you doing all your homework? Sure. Your friend comes to you and says, hey, did you do the homework? Not really. It depends who's asking the question also, that can influence the way you answer, okay? So, any case, many ways, many things that can go wrong with asking questions, basically. It's difficult to make good survey questions. So, example one, let's see if the question may be biased or otherwise introduce bias. And then describe a way to correct the flaw. Okay? An automobile salesman asks former customers, were you happy with your car buying experience? All right. So, an automobile salesman is asking his former customers. All right? So, you can say maybe the questioner is influencing responses. Okay? So if I bought my car from you and then you ask me, am I happy with the service that I got, maybe I don't feel good about telling you, no, your service sucked. Okay? So maybe the questioner, in this case the automobile salesman, is influencing people's responses. So what should you do to fix this? Okay, you should have customers fill out an anonymous questionnaire or survey. Okay? Usually anonymity fixes a lot of problems in surveys. So I can give an honest answer without fearing that I look bad or that I'm going to hurt someone's feelings or something like that. All right? A reporter asks parents, do you agree? A reporter asks parents, do you agree with the high school board's proposal for new technology in schools? All right. What could go wrong here? Do you agree? Okay, this seems fine with the high school board's proposal for new technology in schools. Well, what does that mean? What is the proposal? I don't know. Maybe you don't know. Maybe the parents don't know. Okay? So, this question assumes knowledge of the proposal. Okay? So if I don't have knowledge of the proposal, then I can't really answer the question properly. All right? So the proposal itself should be given to respondents first. Okay? So that they can give an accurate answer. Okay? Once I know what the proposal itself is, then I can say if I agree with it or not. Okay? Dentist asks patients, do you brush your teeth at least twice per day and floss every day? Okay. So here, problem here is if you tell the dentist, no, I don't brush my teeth twice a day and I don't floss at all, you look bad, okay? And your dentist will go, hey, what are you doing? Take care of your dental health. So, problem here is the person asking the question, okay? So, the questioner is influencing your responses, all right? I don't want to tell the dentist I'm not brushing my teeth, so maybe I lie and say, yes, I am brushing my teeth twice a day and flossing. Maybe I don't floss, maybe I only brush once, okay? So if the dentist is asking for general feedback from his patients to see how many of them actually do this, again, it could be an anonymous survey that fixes the problem. But for you specifically, there's not really any way to get around that. It's very difficult. You know, maybe this survey, to make it feel a bit more comfortable, maybe this survey could be, you know, a digital survey or something, but it's really hard to get around the fact that someone has to actually ask you how many times you brush your teeth, okay, and if you do it properly and enough and frequently enough. So, any case, if the goal is to ask patients in general to see what my patients are doing, then again, you could administer an anonymous survey. Okay, an anonymous survey. Okay, that would fix one type of problem, depending on the intent of the question. All right? All right, so, and also, guys, I just want to say that you could probably come up with other problems here that you see. So these are not the only problems. You see other problems, that's fine. It doesn't mean that this is the only thing wrong. This means this is one thing that's wrong with the question or the scenario in which the question is asked. Yeah, I'll leave it at that, okay? And then we want to talk about the difference between experiments and observational studies. So one very easy thing that you can think of to distinguish the two is the treatment, okay? Experiments impose treatment. So that's the simple, short answer. What's the difference between an observational study and an experiment? An experiment imposes a treatment. And then you collect data on the response to the treatment. Okay? Treatment can be anything. Treatment can be all kinds of different things. Medical treatment, temperature of a room, adding something to gasoline, inflating tires with a different type of gas from just regular old air that we get from the pump, all kinds of things. There's so many different things. The treatments can be almost anything. And individuals can also be almost anything. Individuals mean people, animals, objects, plants, whatever, okay? So, in any case, just think about this. An experiment imposes a treatment. If you can't see that there's a treatment being imposed, and imposed means I force you to do it, you don't have a choice, okay? It's not voluntary. So, imposing a treatment, right? If I can't identify that that's happening, it's not an experiment, now it's an observational study. All right? And a good observational study, remember from last section, does random sampling. Okay, I randomly sample people and then I ask them a question or I observe some kind of characteristic of them. Okay, or measure something about them. All right, so in some cases it may be difficult to control or isolate the variable being studied, or it may be unethical to subject people to a certain treatment. All right? Coronavirus is a great example of this. I can't do an experiment to see how long does coronavirus last, how severe are the effects, by forcing people to be exposed to coronavirus and get the disease. That would be an unethical experiment, okay? That would be an unethical experiment. What you can do is ask volunteers who already have coronavirus to be part of some kind of an experiment. That's different, but exposing people on your own to the virus and then doing experiments on them, that's unethical, okay? So in those kind of cases, we do observational study. So you just observe them and measure something after the fact, okay? So observational study is exactly what it sounds like. You observe people, all right? But you don't force them to do something necessarily. You don't impose a treatment, okay? And then see a response to the treatment. That's not an observational study. So observational study is people like maybe you've heard of Jane Goodall, who goes and lives with chimpanzees in Kenya in the forest for 10 years or something, and just watches the animals and hopes that her presence doesn't really impact their behavior too much. Okay, something like that. Observational studies are very difficult, and yeah, so for observational studies also, an experiment, one big thing, and I wonder if this is coming up later, maybe I should, no, yeah, let me stop there, okay? So, example 2, determine whether each situation is an example of an experiment or an observational study, explain. All right, so a landscaper fertilizes 15 lawns, with his regular fertilizer mix and 15 lawns with extra nitrogen in his fertilizer mix. Then compares the results. Okay, so it seems like the lawns are the individuals or subjects. There's two groups, regular fertilizer and extra nitrogen fertilizer. Okay, so if this is regular, that seems like what I normally do in experimentation. We would call this like a control group, the regular situation, and this would be my treatment. Okay, the thing that I've changed, that I'm imposing on something or someone. Now I am imposing extra nitrogen on these 15 lawns. So that's my imposing that treatment. Okay? So we can comfortably say this is an experiment. Not a very clearly designed experiment, but in any case, it's an experiment. The treatment imposed is the extra nitrogen fertilizer mix. Okay? That's it, that's enough. It's an experiment, and that's why. Researcher asks college students how many of hours of sleep they get on an average night, and examines whether the number of hours of sleep affects students' grades. Definitely observational study. Okay. No treatment is imposed. We simply just ask the students what they're already doing. Okay. We are merely asking or about, let me say asking about or observing current behavior. Okay? No treatment imposed. I'm just asking how much you currently sleep. That's not an experiment. Okay? A Parks Department employee wants to know if latex paint is more durable than non-latex paint. She has 50 park benches painted with latex paint, 50 park benches painted with non-latex. Okay? So she's actually interested in this. Is latex paint more durable? So she imposes the treatment of latex paint on 50 park benches. Okay, so this is definitely an experiment. The treatment is latex paint. Okay? All right. And then to test the redesign of its website, an online bookseller assembled 96 users of the site and randomly divided them into two groups. One group used the new website and one group used the old website. Okay? Users of the new site were able to complete the purchase faster. All right. So, again, can I identify a treatment? Yeah, there's a new website. That's the treatment. That's what I want to see if it does something. And this would be my control group, or the old website, or the regular situation. Okay? So this is definitely an experiment. The treatment is the new website. Okay? Something like that. All right. And then this is fine. This is okay. But this should lead you to the question of, well, okay, I understand what's an experiment, but what's a good experiment? So we said with all of this stuff, these are all questions you ask people, usually in an observational study, and we're telling you these are bad questions to ask, and that gives you an idea of what are some type of good questions to ask, mainly maybe anonymous questions and phrase your questions correctly, things like that. Well, the same question arises. What makes a good experiment? Okay, and here is the name of a good experiment: a randomized comparative experiment. Okay, so it has some features that you need to have. So experiment means, first of all, I need a treatment. Okay, comparison means I need at least two groups to compare to each other, and randomization means randomly assign the treatments. Okay, so all of that leads me to the little picture down here. Now this is not in your textbook, this is something we do in AP Statistics, but I just introduced it to you. It's an easy way to remember and understand experimentation. Okay, so this is good experimentation, randomized comparative experiment. So, and we call this, they're calling it a controlled experiment. Okay, in a controlled experiment, two groups are studied, two groups, at least two groups, can be more actually, okay, are studied under identical conditions with the exception of one thing being different, the treatment. So everything for the groups are the same except the treatment, okay? The group under ordinary conditions who do not receive the treatment is called the control over here. The group that is subjected to the treatment is called the treatment group over here, okay? And then in a randomized comparative experiment, individuals are randomly assigned, right here, random assignment to the treatments. And then, because I have two groups, I can compare them, okay? So that's where the comparison comes in. I can compare the results, all right? I can compare the results. So if we look at, let's say, the park bench thing, I would have, maybe my treatment group would be latex paint here. This would be non-latex paint. And I would say my whole list of volunteers, or in this case it would be benches, there would be 100 of them, and I would randomly decide which 50 gets that latex paint and which 50 don't get the latex paint. And you know how to select randomly, okay, you know how to randomly sample. Well, selecting 50 people from 100 to be in a group is the same as a random sample. You sample 50 people from here, so you know how to do that on your calculator already. And then at the end, you would have to decide, what did they say here? It's more durable, okay? So I would compare the results at the end and see more durable. I don't know. What does this, do these benches that had latex paint look better? Is there less wear? Some kind of a measurement you'd have to come up with, and maybe say after a year, you compare the two bench groups to each other and look at each one and go, you know, how much wear and tear did this bunch of benches have and how much did they have? And hopefully the latex painted benches had less wear and tear, or they look better, or some kind of a metric that you've decided on. Okay? So that makes a randomized comparative experiment, all right? So that little picture there hopefully helps you. Like I said, that's not in your textbook, so hopefully that helps you, all right? All right, so let's look at example 3. Example 3 says, determine whether the study described in the health bulletin below is a randomized comparative experiment. If it's an experiment, then describe the treatment group, control group. Okay? Treatment group, and control group. If it's not an experiment, explain why not and discuss whether the conclusions drawn from the study are valid. Lots of stuff to do. So, here's one. At Ashland Middle School, students were given the choice of drinking milk or other beverages at lunch. Ooh, important word. Choice of drinking milk or other beverages at lunch. 50 students who chose milk were monitored for 1 year, as were 50 students who chose other beverages. Okay? At the end of the year, students in the milk group had 15% fewer cavities than students in the other group. Now, let's think about that. Let's think about this. All right. Students were given the choice of drinking milk. So, okay, who are my volunteers? 50 students here, 50 students here. Okay, I guess maybe they're volunteers. Not very clear. Random assignment? Nope. Nope. The students had a choice what they wanted to do. I didn't randomly assign them. Okay, so that's already there. It's not a randomized comparative experiment. Okay, it's not a randomized comparative experiment. Done, because random assignment wasn't done. Okay, there was no random assignment to a treatment and control group. Done. Okay. Okay. So it says if it's not, we did that. This is why it's not a randomized comparative experiment. Discuss whether the conclusions from the study are valid. So at the end of the year, students in the milk group had 15% fewer cavities. Now you should pause the video and think about this very clearly for yourself, please. Always when we do examples, pause the video, think about this clearly for yourself. What could have happened here? Okay, I'm going to give you one thing that could have gone wrong here, okay? So I'm going to say the conclusions are not necessarily valid. In other words, what it would seem like is if you drink milk, you'll have 15% fewer cavities, okay? That seeming conclusion is not correct. Not necessarily correct. We don't know if that's the reason, okay? So you just say the students who chose to drink milk may all just coincidentally have had better dental health. Okay? That's it. Maybe all the people who say I want to drink milk, maybe milk is healthier than other beverages. Maybe the other beverages people chose to drink were all soda. And soda contains a lot of sugar, and that's bad for your teeth and dental health, okay? And so there are so many reasons that you can come up with for this being the case. But maybe the people who drink milk are generally more healthy, eat more fruit and healthy diets, brush their teeth more, go to the dentist more. Maybe that's just milk, choosing milk and those other behaviors go together, and that's why they have better dental health and fewer cavities. We don't know what's going on here. We don't know, we cannot say, so this is a big problem in the real world. People are trying to establish causation. Drinking milk causes fewer cavities. We cannot say that. Okay, we cannot say that. So, that's the problem there. Okay, so not a randomized comparative experiment, no random assignment, and then all these other things can go wrong. Okay, guitar manufacturer, excuse me, has guitar technicians test nickel-plated stainless steel electric guitar strings. You have a technician test nickel-plated stainless steel electric guitar strings. Whoa, okay. By rating their ease of use on a scale from 1 to 10. Okay. 40 technicians are randomly divided into two groups. Ooh, random, good. One group uses regular stainless steel strings. The other one uses nickel-plated strings. Users of the nickel-plated strings gave higher ease of use ratings 90% of the time. Okay. So clearly we want to test nickel-plated stainless steel electric guitar strings. Okay, so this seems like a treatment. that's being imposed. We have the word random, check, okay? So we have a treatment group, okay, that's good. Regular stainless steel, that would seem like a control group. They say that they were randomly assigned to 2 groups. Ooh, that seems good. And at the end, to have higher ease of use ratings means I have to compare ratings. Okay, so yeah, this definitely looks like a, we can say this is a randomized comparative experiment. Okay, and then it said, what should we do? Describe the treatment group, and control group. Okay, treatment is nickel-plated strings. Nickel-plated strings. The treatment group is who? 2 groups, 40 technicians. So it would be the group of technicians who use nickel-plated strings. The group of technicians who used nickel-plated strings, and the control group, I'm going to go down here, would be the group of technicians who used, what was the other one? Stainless steel strings, okay? Stainless steel strings. I think we answered the question, okay? All right, to finish this up, we have a huge topic, all right? And that is causality, all right? We've kind of already said that earlier, right here. Milk does not necessarily cause fewer cavities. So what is a well-designed study? We've seen this. If I'm giving a survey, I have to randomly sample a group. That's the best way to do it. Randomly sample people and put them in a group and then give them a question, okay? If I do an experiment, I have to do this kind of a situation where I have random assignment to treatments. That makes for a good experiment, okay? So, well-designed studies. Randomization is a key element of well-designed studies. How randomization applies to different kinds of studies varies as shown below. Okay, so sample survey. I want to ask people a question. A random sample is selected to be surveyed from the population study. This was section 6.4. Observational study, if it's possible, take a random sample and then study a group. So that's not what Jane Goodall did with the chimps. She found some chimps, she got the right to be there, and she observed them. There was no randomization, okay? But you could, let's say you're a principal and you want to observe students' behaviors in a classroom, you could randomly select some classrooms and then go to those classrooms and observe the students, or the teachers, either way, okay? So you could do observational study with randomization. Experiment, individuals are assigned at random to treatment and control. All right, I think that's pretty straightforward. We've covered that pretty well. So, surveys do not compare groups, so they do not address cause and effect. Oof, you need to circle, underline, highlight. This is a huge idea, okay? Surveys and observational studies do not address cause and effect, okay? I don't compare groups, I don't impose a treatment, I don't control the environment, none of that. I merely look at what's already happening. So I cannot establish cause and effect with a sample survey or an observational study. The only thing that gives me cause and effect is a well-designed experiment. So good observational studies and experiment are designed to be comparative, to compare data from two or more groups, looking for a relation between variables. Okay, in an observational study, like this one with the milk, this was an observational study. I had two groups, but there was no randomization. Okay, so that's an observational study. I compare things, great, but here's the main thing you have to get. Only a well-designed experiment can determine cause and effect. Only a well-designed experiment can determine cause and effect. Okay? So something like this right here, this was a well-designed experiment. That could tell me that nickel-plated strings are easier to use than stainless steel strings. Conclusively, if I use nickel-plated strings, that causes higher ease of use. That's causation. Okay? Only from a random comparative experiment. Okay, randomized comparative experiment. So only from here do I get causation. A causes B. Okay? All right, so an observational study can identify correlation, or what we like to call association. Okay? Correlation or association between variables, but not causality. So what does this mean? Correlation and association. That's not a good word to just casually throw out at you. Okay? What this means is A and B happen together in a certain way. Okay? That's what association or correlation means. And you've done the correlation graphs where we had the dots and we said, oh, that's positive correlation. As A gets bigger, B also gets bigger. Okay, that's an association. And the number that comes from how strong the association is what we call correlation. Okay? So, that's not actually part of this lesson, right? That's a whole big topic on its own. Correlation and association is a huge topic for AP statistics. So, observational study can identify those things, but not causation. I can't say A causes B. Okay? Variables other than what's being measured may be affecting results in an observational study. So, like I said to you earlier with the milk, this situation, we could just all coincidentally have better dental health. That's a variable, my prior dental health, that affects the results. How many cavities do I have after a certain time? Okay? At the end of the year in that case. So, for example, vigorous exercise in older people correlates with longer life. But comparing groups only on exercise and lifespan ignores other factors, such as that people who are unhealthy to begin with may not be able to exercise vigorously. Okay? And then a rigorous randomized comparative experiment by eliminating sources of variation other than the controlled variable can make valid cause and effect conclusions possible. Let's go back to our picture and I'll show you what this means. Okay? When you do this right here, when you do this part right here, when I randomly assign people to treatment and control group, what we say is that these two groups are roughly equivalent, okay? As far as I can tell, because I randomly put people here and I randomly put people here, the groups are about the same now. Okay, there's no reason for me to think that one group contains a bunch of individuals that are some way different from the other group. I can't tell that because they randomly got there. Okay, so the function of this is to create two roughly equivalent groups that I go, they're about the same, and then we just look at the responses to the treatment. Okay, and so Eliminating sources of variation. So if I make the groups roughly the same, then they're not varying much from each other. All right? That's what randomized assignment does. All right? And therefore, in the end, I can say, well, the groups were roughly the same. The only thing that's different in the end is how they responded to this treatment. Okay? Hopefully, that's what you're hoping to see. So, just remember, only a randomized comparative experiment gives me causation. That's it. Okay? Observational study and a sample survey, they don't do that. Okay? All right, so let's do the last example. We'll be out of here. Example 4 says, explain whether the following research topic is best investigated through an experiment or an observational study. Okay? Explain whether the following research topic would be best to do as an experiment or observational study. Then explain how you would design the experiment or observational study. Okay? So, you want to know if listening to music using earphones for more than 1 hour per day affects a person's hearing. Okay, so I want to see if using earphones affects hearing. Okay, so I want to, actually the goal is to, if you can, establish causation. Earphones causes bad hearing or worse hearing. The problem with that is I can't ethically do that. Okay, so you say an experiment that would, and they're saying affect, we assume negatively affect a person's hearing, would be unethical. I can't assign you to a group of people wearing earphones if I think that your hearing is going to get worse by being in the experiment and listening to music on earphones. That's crazy. You can't do stuff like that, okay? And actually, there are ethics review boards. When you do experiments through a university or a college or anywhere, you have to go through an ethics review board. You have to get approval for your experiment from the government, all kinds of things. You will be stopped from doing this by, if you follow the right procedures and you go through the official channels, okay? If you do this in your basement somewhere that no one knows about, of course you can do whatever you want. But if you're doing it and trying to be honest and follow the law, then yeah, this would be frowned upon and they would tell you not to do it, okay? So, what can I do? I must do an observational study, okay? So, we need, we need to do an observational study, okay? And so what I can do is do some kind of a comparison study. Okay, comparison is still good, so I can say recruit individuals who already listen to music, individuals who already listen to music using earphones, and recruit other individuals who don't listen to music using earphones, okay, and then I'm sorry, it's more specific than that. For more than 1 hour per day, okay? For more than 1 hour per okay? And then what would you do? You would say, maybe give each group a hearing test and see if the people with earphones have higher or worse hearing than the people without, who don't use the earphones, okay? Maybe administer a hearing test or something like that to see if people using earphones have worse hearing. Now, again, this will not establish causation. You can't say that's what earphones cause bad hearing, but you can say that there's association, okay? This will at best establish association. So people who use earphones for more than an hour a day, they tended to have worse hearing, but we're not saying they necessarily definitively cause you to have bad hearing. Those things just occur together, okay? Which is very different from saying causation. All right. Then, you want to know if eating oatmeal for breakfast every day will lower a person's cholesterol level. Okay. So what you can say is, get some volunteers. So I think there's obviously not an ethical problem here. Okay. If I don't change anything you do, and your cholesterol level stays what it is, I'm not doing anything bad to you. If I think eating oatmeal will lower your cholesterol, then I'm doing something good to you potentially. So there's not really an ethical problem here. I think some people would say it's unethical to do something good for some people and not for others in an experiment, but this doesn't seem like a big problem. So maybe we could just draw the picture. This would be the easiest to do this. You just say, get some volunteers, okay, and then do what we said there. Do random assignment to groups. And what are my two groups? Okay. My treatment group and my control. And my treatment would be they eat oatmeal for breakfast. And these guys eat what they normally eat, but not oatmeal. Okay? That would be maybe difficult to do, but you have those two. And then at the end, you compare cholesterol levels. After, I don't know, maybe a year, okay? After a year, something like that. All right? So you get some volunteers, randomly assign some. You're going to eat cholesterol. You're going to eat cholesterol. That would be bad. You're going to eat oatmeal. The rest of you are not going to eat oatmeal for breakfast, whatever you normally eat, or, we're not going to change anything you do. And then at the end of, let's say, a year, you compare cholesterol levels. And then if these guys' cholesterol went down, And also, I have to say this to you, this is kind of tricky. How you recruit the volunteers is difficult, okay? How you recruit the volunteers is difficult. So you'd have to say, recruit people with a, similar cholesterol level. Let's say they all have high cholesterol to begin with, or something like that. Picking your volunteers is another thing that's quite difficult in an experiment. But this would suffice for our class. Okay, guys, I hope that was clear to you. Let me know if you have any questions.